So in this question here, we're given a diagram and we're told that ABCD is a parallelogram and that ABP and QDC are straight lines and that the angle ADP is equal to the angle CBQ, which are 90 degrees. Now just looking at that diagram, so ABCD, this shape here is a parallelogram. That means that AD is parallel to BC, because parallelograms have two sets of parallel sides, so these two are parallel, and that's denoted by this little arrow that we have here. And we're also told basically that AB is parallel to DC, but ABP is a straight line and QDC is also a straight line, so if AB is parallel to DC, ABP, this whole line here, is parallel to this whole line here, and that's denoted by these two little arrows. There's two here just to show that these two lines are a different set of parallel lines that aren't parallel to the other set. We also have the two right angles that are already drawn out here, which are 90 degrees. And we are asked to prove that the triangle ADP is congruent to the triangle CBQ. So ADP is congruent to the triangle CBQ. Now, the word congruent here is obviously jumping out to me, and there are a few different ways that we can prove two triangles are congruent. So, proving that they're congruent, we need to prove that they're exactly the same. They have the three same sides and the three same angles. And we can do that by showing that the sides of one triangle correspond and are equal to the sides in the other triangle. So side, side, side. We could alternatively do side, angle, side, so showing that two sides in one correspond to the other, and then there's an equal angle in both triangles, which is in the same place. Alternatively, we can do angle, side, angle, so this is the same, but showing that there are two angles and a side in the first one, which are equal to two angles and a side in the other triangle. We can't, however, do angle, 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 because this could lead to the three angles in the triangle could be the same, but the triangle could be scaled up or down, leaving it with different side lengths. So this doesn't prove congruency. So we basically need to look at these and find a way of proving that these triangles that we have are congruent. Now what I'm initially noticing here is that we already have two angles. Both triangles have a right angle in, they both have a 90-degree angle. So we're going to be using one of these two, so we need to work out how we're going to prove this. We need to find other sides and angles within the triangle which are going to be the same as the other one. So I can firstly write down that we have two right angles here. So we have the angle ADP is equal to the angle CBQ. And that's what we're given in the question. We're told that both are 90 degrees. So here, we've kind of given our first point of reasoning in this proof. We have an angle which is equal in both triangles. So then moving on again, looking at the triangle ADP, we have this side here, side length AD, and side length BC. Now these are parallel, they're in a parallelogram, and opposite sides of a parallelogram are going to be equal. ADP is obviously, the side length AD is obviously in the triangle ADP, the side length BC is in this triangle here. So we have an equal side length in both triangles, and I can write this down too. So AD is equal to BC, and we do just need to give a little bit of reasoning here just to support our proof. And I'm just going to write down the opposite sides of a parallelogram are equal. And that is enough reasoning to get us the marks here. So we now have an equal angle and an equal side length, so we need another angle or another side length. Now again, thinking of the properties of a parallelogram, instead of opposite sides this time, I'm thinking about opposite angles in a parallelogram being equal. So if opposite angles in a parallelogram are equal, and this is the parallelogram we have here, this one's not going to be too useful because it's already including the right angle. Then we've got this little extra angle here, which isn't an angle in the triangle we're interested in. However, these two angles, these opposite angles, are interesting because those are in fact in the triangles that we're looking at. So triangle ADP, this angle is in the triangle, and in this triangle here, it includes this angle. And we know that these are going to be the same because opposite angles of a parallelogram are equal. So I can write that out as the angle PAD, so PAD, this angle in here, is equal to the angle QCB. And again, just writing out the reasoning, and that's because opposite angles of a parallelogram, again, are equal. So we've given that reasoning here. So now we've proven that there's an angle and a side and another angle in the first triangle which is equal to that of the second triangle. So we can therefore conclude that therefore the two triangles must be congruent. And that is by the principle that we've used, angle, side, angle. So there are two angles and the side. Now, as for how the marks are awarded for this proof question, the first mark is for one of these first correct statements, for kind of starting off the proof, identifying a pair of relevant equal sides or angles with reasons. The second mark is for all three of these correct kind of points and with their respective reasons. So we need to make sure we state the reasons as this is a proof. And then the third and final mark is for a conclusion of the congruency proof, and we must refer to the ASA, angle side angle principle in this case. Just a reference to that gets us the third mark for the conclusion here. So now for the second part of the question, I'm asked to explain why AQ is parallel to PC, so explain why these two sides are parallel. Now initially here, just looking at these two sides, I'm thinking back to part A of the question. So we were working with a parallelogram and we used the fact that opposite sides in a parallelogram are equal and that they're parallel to one another. Now looking at this shape that we have here, now looking at AQ and PC, if we were to take this shape APCQ, kind of linking these two sides that we're interested in together, if we could prove that this were a parallelogram, we'd be able to show that these two sides are in fact parallel, which is what we want to explain. So if we look at the other sides, AP and QC, now these are both part of the triangles that we proved were congruent previously. So AP is the hypotenuse of this triangle here, and then QC is the hypotenuse of this triangle here. And we know that the triangles are congruent, so their hypotenuse must be equal. So that is the first point I'm going to make here. I'm going to say that AP is equal to QC. And that is since triangle ADP is congruent to triangle CBQ. And that's what we proved in part A. So now using this, we know that these two sides are equal, and they're two equal parallel sides, which we can therefore take as the opposite sides of a parallelogram. So, going on a bit further, if these two sides are equal and parallel, and we can basically join them up with these two sides to create the parallelogram, we know that these two sides must be equal and parallel. So now we just need to explain why AQ is parallel to PC, and we can just reason that APCQ is a parallelogram. It has two sets of parallel sides which are equal. So AQ is parallel to PC as opposite sides of a parallelogram are in fact equal. So the first mark here was awarded for this initial reasoning, so for identifying a pair of equal sides or angles would also work in APCQ, this parallelogram, with some reasoning. And then the second mark here is for reasoning that APCQ is a parallelogram and its opposite sides are therefore parallel and equal. So we therefore have AQ being equal and parallel to PC. So we've explained why the two are parallel.